Hello, Math 0092. We're going to begin with section 2.6, where we're multiplying, simplifying, and applications, with primarily looking at our fractional notation. So with fractions, we may want to multiply them. 3/8 times 4/9. 3/8 times 4/9. Multiplication. Piece of cake. Multiplication of fractions is a piece of cake. Multiply the numerators, multiply the denominators, and simplify if you can. Well, that's even. So I know 2 will go into the numerator, 2 times 6, and 2 goes into the denominator, be 36. Still even, but 6 goes into 36 and 6. 6 goes into 6 once, and 6 goes into 36 6 times. So simplified, my answer is 1/6. Multiplied. 6/7 times 5/3. Multiplication. Is a piece of cake. Multiply the numerators, multiply the denominators, and simplify if you can. Well, I know that 3 goes into 21. 2 plus 1 is 3. The divisor rules. The sum of the digits is divisible by 3. So 3 goes into 30 10 times, and 3 goes into 27 7 times. 7 is prime, so my simplified answer is 10/7. On page 125. Example 4, landscaping. Selena's landscaping uses 2/3 pound of peat moss when planting a rose bush. How much will be needed to plant 21 rose bushes? So each rose bush needs 2/3 pound. And we want to plant 21. So I have 21 times 2/3 pounds of moss. Interesting to note, 21 is a whole number, and we can write that in fractional notation with a numerator and a denominator as 21 over 1. 2 times 21 would be 42. Multiply the numerators, multiply the denominators. 1 times 3 is 3. But we always want to simplify. Now 4 plus 2 is 6, and 3 goes into 6 evenly. So 3 goes into 42 16 times, and 3 goes into 3 once. So we state that the landscaper will need 14 pounds of peat moss to plant 21 rose bushes. Oh, let's see. I got 16. Oh, yes. 3 goes into 42. 3 goes into 42 once would be 3. And 12. 3 goes into 12 4 times. So this should be 14 pounds of peat moss. So the landscaper will need 14 pounds of peat moss to plant 21 rose bushes. This this is in the margin on page 125. Number 5. Chocolate Delight sells 4/5 pound boxes of truffles. How many pounds of truffles will be needed to fill 85 boxes? So if I have 85 boxes, each filled with 4/5 pounds of truffles, I have 85 times 4/5 pounds. Now 85 is a whole number. I can write that in fractional notation with a numerator and a denominator as 85 over 1. And I see that 5 goes into 85 evenly. 5 goes into 85 evenly. $85 divided by 5 is 17. And what's left? Times 4 over 1. 5 goes into 5 once, and 5 goes into 85 17 times. 17 times 4 is 68. So the number of pounds of truffles that we need to fill 85 boxes with 4/5 pounds each is 68 pounds. On page 129, we want to be able to read circle charts. Number 57, a family has an income of $42,000. Of this, 1/5 is spent for food, 1/4 for housing, 1/10 for clothing, 1/14 for savings, 1/5 for taxes, and the rest for other expenses. How much is spent on each category? Well, here's our circle chart, and we can see that food is 1/5. Other expenses is represented. Taxes is 1/5. Savings is 1/4. Clothing represented by 1/10, and housing represented by 1/4. So if 1/5 is spent on food of my $42,000, I want to find out how much is spent on food. 42,000 is another whole number, so we can write that in fractional form with a numerator and a denominator of 42,000 over 1. Multiplication of fractions is a piece of cake. Multiply the numerators, multiply the denominators. I get 42,000 over 5. $42,000 divided by 5 is $8,400. My next category is housing. And 1/4 is spent on housing. 1/4 of my total earnings is spent on housing. 42,000 can be written as 42,000 over 1. Multiplication of fractions is a piece of cake. Multiply the numerators, multiply the denominators. 42,000 divided by 4 is $10,500. So of my total earnings for housing, I spent $10,500. 1/10 is spent on clothing. 1/10 of indicates multiplication, $42,000. 42,000 can be written in fractional form as 42,000 over 1 with a numerator and a denominator. Multiplication is a piece of cake. Multiply the numerators, 42,000. Multiply the denominators. And 42,000 divided by 10 is 4,200. So $4,200 was spent on clothing. Savings. 1/14 of my total saving. Of represents multiplication. 42,000 divided by 14. Multiplication of fractions of a piece of cake. Multiply the numerators, multiply the denominators. And 42,000 divided by 14 is 3,000. Taxes. I spent 1/5 on taxes. 1/5 of represents multiplication. That's 42,000 divided by 5. Oh, 42,000 divided by 5 is 8,400. And the rest was spent on other expenses. So total for my category so far, I have 8,400 plus 10,500 plus 4,200 plus 3,000 plus 8,400. So my other category is the balance of 42,000 minus the total that I've had budgeted so far of 34,500. Finding the difference, I get $7,500. So the other balance is $7,500. Taxes was $8,400. Savings $3,000. Clothing $4,200. Housing $10,500. And food $8,400 for a total of $42,000. Multiplication of fractions is a piece of cake. Multiply the numerators, multiply the denominators, and simplify if you can. Section 2.7. We're introducing a new term, reciprocals. The product of two numbers is 1. And if the product of those two numbers is 1, we say they are reciprocals of each other. To find the reciprocal of a fraction, interchange the numerator and the denominator. So if my number is 3/4, its reciprocal is 4/3. Three-fourths So if my number is 3/4, I'm going to interchange the numerator and the denominator and get 4/3. If my number is 7/8, I'm going to interchange the numerator and the denominator and get 8/7. If my number is 1/5, I'm going to interchange the numerator and the denominator and get 5/1, or 5 as a whole number. Now we use reciprocals as we continue to divide and solve for applications. The number 0, or 0 over n, has no reciprocal. Remember that some number over 0 would not be defined. So we could not have 0 in the denominator when we interchange. So 0 does not have a reciprocal. So how do we divide fractions? 2/5 divided by 3/4. Well, this is our division symbol, and it really means 2/5 divided by a fraction 3/4. Now, if I multiply by the reciprocal, interchange the numerator and the denominator in the denominator's position, I get 12/12. But if I multiply by the reciprocal in the denominator's position, I'll have to multiply by the reciprocal in the numerator's position. 4/3/4 is another name for 1. And any number times 1 is the number itself. It may not look the same, especially in fractions, but it has the same value. Multiplication of fractions is a piece of cake. Multiply your numerators. Multiply your denominators. I have 8/15 over another name for 1. So my answer is 8/15. Now what did we do? We actually multiplied the numerator by the reciprocal of the denominator, knowing that the denominator would then go to another name for 1. If I multiply a number by its reciprocal, its product is 1. 12/12 is another name for 1. So if I know that's going to happen, I simply multiply the first fraction by the reciprocal of the divisor. Let's try that. 2/5 divided by 3/4. Change division to multiplication and multiply by the reciprocal. Change division to multiplication, and we have to keep the pendulum balanced. If I do one thing, I have to do something else. Change division to multiplication and multiply by the reciprocal of the divisor. Interchange the numerator and the denominator. Multiplication of fractions is a piece of cake. Multiply the numerators, multiply the denominators, and simplify if you can. We had no number that went into 8 and 15 evenly. So much simpler on this side, and we know why on this side. So division we're defining in terms of multiplication. 7/8 divided by 1/16. Change division to multiplication and multiply by the reciprocal of the divisor. 7 times 16. 7 times 16 is 112. Multiply the denominators, it's 8. And 112 divided by 8 is 14. Two-fifths divided by 6. Careful, in this example, we have a whole number, and in fractional form, I can represent that as 6/1 with the numerator and the denominator. Dividing fractions, I change division to multiplication and multiply by the reciprocal of the divisor. Multiplication of fractions is a piece of cake. Multiply the numerators, multiply the denominators, and simplify if you can. Our divisibility rules from chapter 2 help us out on this earlier, where we learned that if our 1's unit is even, it's divisible by 2. So 2 goes into 2 once, and 2 goes into 30 15 times. Two-thirds divided by 7/5. Once again, we're defining division of fractions in terms of multiplication. 2/3. I'm going to change division to multiplication and multiply by the reciprocal of the divisor. Multiplication of fractions is a piece of cake. Multiply the numerators, multiply the denominators. And that is simplified. Four-fifths divided by 8. Just a reminder, this is a whole number, and to represent it in fractional notation, I have a numerator and a denominator as 8/1. My rule for division of fractions is to change division to multiplication and multiply by the reciprocal. Multiplication of fractions is a piece of cake. 4 times 1 is 4. 5 times 8 is 40. Simplify if you can. Well, 4 goes into the numerator and 4 goes into the denominator. 4 goes into 4 once, and 4 goes into 40 10 times. On page 132, example 9. How many doses, each containing 15 force milliliters, can be obtained from a bottle of children's antibiotic that contains 60 milliliters? So we're going to have 15 force, 15 force. Each dose is 15 force, but how many of them are we going to have if I have a total of 60 milliliters? So what's my total number when I have 60 millimeters divided by 15 force milliliters? Remember that 60 is a whole number. We can represent that in fractional notation as a numerator and denominator, 60/1. We change division to multiplication and multiply by the reciprocal of the divisor. 4 times 60 is 240. 1 times 15 is 15. And I know that 5 goes into any number that ends with 0 or 5. So 5 goes into 240 and 15. Let's see if 240 is divisible by 15. 16 times. So the total number of doses is 16 doses, each 15/14 milliliter from a bottle that has a total quantity of 16 milliliters. Stated. There are 16 doses in a 60 milliliter bottle of antibiotic. Bicycle path. The city of Indianapolis has adopted the bicycle master plan as a strategy for creating an environment where bicycling is a safe, practical, and enjoyable transportation choice. After the city finished constructing 60 miles of bike paths and on-road bike lanes, the master plan was 3/10 complete. What is the total number of miles of bicycling surface that the city of Indianapolis plans to construct? Well, so far, they have a fraction completed. And that fraction is 3/10 of the project. 3/10 of the project times the total for the bicycle strategy plan is equal to the amount completed so far. And so far we have 60 miles completed. So 3/10 of the total project is equal to our completed project so far of 60 miles. Well, we're solving for B in this case as a goal or strategy. We want to be able to say B equals. So we need to isolate B. And I have 3/10 times B equals 60. I remember my multiplication principle. Multiply any number times 1, and I'll get the number itself. So if I multiply by the reciprocal, 3/10, if I multiply by 10 over 3, any number times its reciprocal is 1. 30 over 30 is another name for 1. And 1 times B would leave B equals. So I'm getting pretty close to my goal. But I must remember that I used a strategy. I multiplied by the reciprocal on this side of the equation, so I have to multiply by the same thing on this side of the equation. I need to keep my pendulum balanced. There was a reason why I multiplied by 10/3. It was the reciprocal of 3/10. 10/3 times 3/10 is another name for 1. 1 times B isolated my variable. But if I multiply by something on this side of the equation, I have to multiply by the same thing on the other side of the equation. This is 60 over 1 times 10 over 3. So I get 60 times 10 over 3, and 3 goes into 60 20 times, and 3 goes into 3 once. That's all multiplication, so I can divide 3 into 60 and get 20, and 20 times 10 is 200. So the total project for the bicycle plan will call for 200 miles. Stating our answer, the Indianapolis Bicycle Master Plan calls for 200 miles of bicycling surface. Okay, just reviewing, if I have 5/6 as a number, its reciprocal is interchange the numerator and the denominator. Why? Because a number times its reciprocal must be equal to a positive 1. Let's see, multiplication of fractions, 30 over multiplication 30 is another name for 1. 1 over 1. 30 over 30 equals 1. I have 18/5 as a number. Its reciprocal is 5 over 18. Interchange the numerator and the denominator. If I'm dividing fractions, 3/5 divided by 3/4. I remember that I change division to multiplication because multiplication of fractions is a piece of cake. If I change division to multiplication, I need to also change the divisor to its reciprocal. So when we're dividing fractions, we change division to multiplication and multiply by the reciprocal of the divisor. Now, multiplication of fractions is a piece of cake. We get 12 over 18. 3 goes into each of those. 3 goes into 12 4 times, and 3 goes into 18. 5 times 3 is 15. Sorry. 3 goes into 12 4 times, and 3 goes into 15 5 times. Our answer is 4/5. 5 times 3 is 15. 18/5 divided by 2. Here we want to remind ourselves that 2 is a whole number and can be represented in fractional form as a numerator over a denominator, 2 over 1. Multiplying fractions, we change division to multiplication and multiply by the reciprocal. Interchange the numerator and the denominator. Multiplication of fractions is a piece of cake. Multiply the numerators, multiply the denominators, and simplify if you can. Well, 2 goes into 18 9 times, and 2 goes into 10 5 times. On page 136, number 42. Benny uses 2/5 gram of toothpaste each time he brushes his teeth. If Benny buys a 30-gram tube, how many times will he be able to brush his teeth? So he has this full tube of toothpaste at 30 grams, and he uses just 2/5 gram each time. So how many times will he be able to use 2/5 gram from a 30-gram toothpaste tube? So he has 30-gram toothpaste tube, and we want to divide that into equal parts of 2/5. 30, we remember, is a whole number. It can be written in fractional form, 30 over 1. Dividing fractions, we change division to multiplication and multiply by the reciprocal. Interchange the numerator and the denominator of the divisor. Multiplication of fractions now is a piece of cake. 30 times 5 is 150. 2 times 1 is 2. And 2 goes into 150 75 times. So Benny will be able to brush his teeth 75 times with 2/5 gram of toothpaste each when he has a 30-gram toothpaste tube. A child's baseball shirt requires 5/6 yards of fabric. How many shirts can be made from 25 yards of fabric? So if we have 25 yards of fabric, how many individual shirts of 5/6 yards each can be made? I have 25 yards. I want to divide that into equal 5/6 yards for each shirt. A whole number. We remember division of fractions. Excuse me. We change division to multiplication and multiply by the reciprocal of the divisor. Five goes into 5 once, and 5 goes into 25 5 times. 5 times 6 is 30, and 1 times 1 is 1. So we have 30 shirts can be made from 25 yards of material when each shirt requires 5/6 yards. We talked about prime numbers. The definition is on page 88 in your ebook. And remember that prime numbers are whole numbers between 1 and infinity that have as factors only themselves and 1. 1 is not a prime number because 1 times 1 times 1 times 1 times 1, it has a potential for many factors. A prime number has only 2, itself and 1. Well, 2 is a prime number. 2 times 1 is 2. There are no other factors. 3 is a prime number. 3 times 1 is 3. 4, however, is 1 times 4 and 2 times 2. 5, we can factor as 1 times 5. There are no other factors. 6 is even, so we know 2 will go into that even number, as well as 1 times 6, 2 times 3. And actually, any even number would not be prime because it has itself and 1 and 2 at least as its factor. 7 is prime. It has factors of 1 times 7. 8 is even. 9 has 3, so 1 times 9 and 3 times 3. 10 is even. 11, only 1 in itself. And what I'd like you to do is visit this handout and kind of work through and make sure that you can find the prime numbers between 1 and 100 and why. And the handout continues to give you the divisibility rules for each of the numbers 1 through 100. And know that recently the newest, largest prime number was found. And if you search the internet, you'll be able to find the massive, huge, long, lengthy number represented as our newest prime number. This is interesting. It's information you should know and understand. And it's a handout that's available at your D2L website. Spend a little time investigating prime numbers. And if you get a chance, look up our newest prime number that was recently found. It is not graded. It's for learning purposes only. And then we continue with our chapter summary and review on page 138. We're supposed to find the factors of 140. Factors of 104, I'm sorry. The factors of 104. Well, 2 times 52. 2 is prime, I'll carry that down, but 52 can be factored as 2 times 26. 2 is prime, 2 is prime, but 26 can be factored as 2 times 13. So I have 8 times 13. 8 times 13 is 104. So my factors are 1, 2, 4. This is 4 times 26. 8, 1, 2, 3, 8 times 13 times 26 times 52 and times 104. So we're matching up our factor pairs. And listing the factors 1, 4, 8, 13, 26, 52, and 50, and 104. And I use my factorization tree to factor. I learned all of the factors from the factor tree, and the prime factorization is unique. Remember, every whole number has a unique prime factorization, and the prime factorization is 2 times 2 times 2 times 13. Next, we're asked to simplify 0 over 18, 18 over 18, and 18 over 1. 0 over any number other than 18, other than 0 would be 0. 0 over any number other than 0 is 0. 18 over 18 is another name for 1. 18 over 1 is another name for 18. And 18 over 0 is undefined. We cannot divide by 0. 0 division by 0 is undefined. So they're just pointing out that we have to be careful. There are those special cases with 0 and other names for 1 when we're working with fractional form. Find a name for 7/12 with a denominator of 96. So we have 7/12, And we want to find its equivalency with a denominator of 96. So 96 divided by 12 is 8. So if I take 12 times 8, I'll get 96, which is what I'm looking for. But if I multiply the denominator by 8, I'll have to multiply the numerator by 8 as another name for 1. Remember, 8 over 8 is another name for 1. And 1 times any number doesn't change its value. It may change its looks. 8 times 7 is 56. So 7/12 is equal to 56/96. And they're not asking you to simplify that because we want to find what 7/12 is equal to in 96. So your answer is 56/96. Simplify 100 over 280. 100 over 280. Well, simplifying, if 0 is in the ones digit, I know I can divide by 10. So 10 goes into 100 10 times, and 10 goes into 280 28 times. My ones unit is even, so I know 2 will go into the numerator 5 times, and 2 goes into the denominator 14 times. And 5 does not go into 14, so simplified. 100 over 280 is simplified to 5/14. Use an equal sign or a not equal sign to write a true sentence. 8 over 48 compares to 6 over 44. Well, in order to determine equivalency or not equivalency, I need a least common denominator. I have to make sure that both pies are cut into the same wedge. Now I can simplify this. I see that 8 goes into 48. 8 goes into itself once, and 8 goes into 48 6 times. Put 8 over here. And this is even, so at least 2 goes into that. So let's put a 2 over here. 2 goes into 6 3 times, and 2 goes into 44 22 times. So now I can build my least common denominator chart, 6 and 22, picking up all the denominators and factoring 2 times 3 and 2 times 11. I need a factor of 2. I need a factor of 3. I already have a factor of 2, but I need a factor of 11. So 6 times 11 would be 66. My common denominator is 66. I want to convert 6 to 66. 6 times 11 would be 66. So I need to multiply my numerator times 11 as another name for 1. 11 times 1 is 11. I want to convert 22 to 66. 3 times 22 would be 66, so I need to multiply the numerator by 3, and 3 times 3 is 9. 11/6 is not equal to 9/66. So we can state that 8/48 is not equal to 6/44. We're asked to multiply and simplify, or divide and simplify, I'm sorry. 9/4 divided by 45/14. We remember that division of fractions, we change division to multiplication and multiply by the reciprocal of the denominator, of the divisor. So we interchange the numerator and the denominator. Multiplication of fractions is a piece of cake. 9 times 14 is 126. 4 times 45 is 180. This even is even. I know at least 2 will go into each. So 126 divided by 2 is 63. And 180 divided by 2 is 90. Some of the digits, 6 plus 3 is 9, and that's divisible by 3. 90 is divisible by 3. 3 goes into 63 21 times, and 3 goes into 90 30 times. 3 goes into that. 3 goes into 21 7 times, and 3 goes into 30 10 times. And we have simplified 9/4 divided by 45/14. A flower vase has 7/4 cups of water in it when it is 3/4 full. How much can it hold when it's full? So our flower vase has about 3/4 full, which is equal to 7/4 cups. So 3/4 full, 3/4 times full is equal to 7/4 cups. We want to know how many cups are available when it's full. So 3/4 of means multiplication of, when it's full, is equal to 7/4 cups. We're going to use our multiplication principle. We're going to multiply by the reciprocal, 4/3, on both sides of our equation. This goes to 1. A number times its reciprocal is 1. 1 times f would be f equals. On this side we have 7/4 times 4/3. 7 times 4 is 28, and 4 times 3 is 12. 4 goes into 28 7 times, and 4 goes into 12 3 times. So when our vase is full, there will be 7/3 cups in the vase. I have 7/3. 7 is the numerator, and 3 is the denominator. Remember, the denominator is down. All right, please return to D2L, the overview document. Read the overview document where all assignments, details, and their due dates are published. And that completes Chapter 2. Thank you very much.